mock exam for functions. A relation G is given by G maps x to 2x minus 3, where x is an element of the set -2, 2, and 3. Draw a mapping diagram to illustrate this relation. Okay, so I am going to draw the two ovals that represents the sets. I'll call them A and B, like we usually do. And then I will put each of the domain values in the left oval, -2, 2, and 3. And I'm going to find out what those map to. Okay, and the mapping is called G. So I'm going to put G there. I'm going to use the calculator to figure out what those map to. And since I need to figure out the mapped value for -2, 2, and 3, and there's 3 numbers, I'm going to use the y equals function instead of just typing out each one individually. So I go to y equals and I type in 2x minus 3. And then I look at the table, because in the table it'll already give me the values for 2 and 3x. So x equals 2, x equals 3, they're right here. They map to 1 and 3 respectively. I just need to find out what -2 maps to. I can figure it out by pressing the up arrow twice, and then I can see that -2 maps to -7. So I'm done with my mapping here, okay? And let's go to the next one. Hence or otherwise justify that the relation is a function. Remember, to be a function, there needs to be either a one-to-one or a many-to-one mapping, and in this particular case it's a one-to-one mapping, so I can say that it is a function because it's a one-to-one mapping. Is the function G linear? Okay, so there's a couple ways to do this. One is to look at the equation here, which you can relate to y equals 2x minus 3 and say, oh, this is y equals mx plus c. So it is linear because it's in slope-intercept form, gradient-intercept form. Another way you could do it is you could go to stat edit and you could put in the numbers, the ordered pairs here, -2, -7, 2, 1, and 3, 3. And then we could, let's do this. Let's turn off, I'm going to turn off this function by toggling the equal sign. I press enter on top of the equal sign and it won't graph it anymore. And then I'm just going to graph these values here. Let's see if they graph. No, they don't, because I need to turn them on. I go to second stat plot and then I turn this plot on. I'm going to press on, and then the default is already scatter, so that's fine. L1 and L2, that's fine. And then now I'm going to graph again. And I can see that these 3 points are in a line. Okay? Okay, and so, yes, it is linear. Write down the range of function G. And in this particular case, the range is going to be these 3 numbers here, right? So I'm just going to make a set here. -7, 1, 3, because those are the 3 numbers that are in the range. I could say something like G of x is an element of -7, 1, 3, but just the set is fine. Justify that the function G has an inverse function. Okay, so remember, for a function G to have an inverse function, it has to be a one-to-one mapping. Remember that a one-to-one mapping or a many-to-one mapping can both be a function. But only a one-to-one mapping can be a function that has an inverse. Okay? So we're looking to see if it's a one-to-one function. Yes, it is. So yes, it is, because it's a one-to-one mapping. Okay? Okay. and draw a mapping diagram to illustrate the inverse function of g. Okay, so that would be the same A and B sets, except now all the arrows go backwards. And the mapping arrow goes backwards also, but instead of having g here, we're going to have g to the -1 power, which is notation for the inverse function of g. Okay. Let's go to number 2. Bert, a plumber in Australia, charges 90 Australian dollars per hour for work plus a fixed cost. His total charge is represented by the cost function B of t equals 60 plus 90t, where t is an hour. So we recognize that the 90 per hour appears here, and it's multiplied times the t at time, which makes sense. Write down the fixed cost for Bert. So remember, his total charge is a fixed cost plus the 90 per hour rate, and so it's obviously 60. It takes 2.5 hours for Bert to complete a job. Find the total cost of the job. Okay, so let's go back to the calculator, and I'm going to turn off my plotting of the stat edit data so I don't mess up my other graph. And now and for y equals, I'm going to put the new function 60 plus 90x. Okay, and then I'm going to see how long it takes to get, or if it's 2.5 hours to complete a job, what is the cost of the job? First thing I'm going to do is look at the table. And when I look at the table, if it was 2 hours or 3 hours, I could see that it costs 240 or 330 respectively, but it doesn't say 2.5. How could I do that? How could I see 2.5 hour jobs on this table? I could just change the incremental step to 0.5. If I do, then it'll show me the value for x equals 2.5 also. It is 285. Okay. Another way to do it without having to do that is to go to the graph and then do trace 2.5. Now it's off the screen, so let's do a zoom fit. Which is option, I think 0. Yeah, option 0. And then the y coordinate of the y scale will adjust so that we can see the whole thing. And then we're just going to do trace 2.5, and then hopefully we'll see the value here. So we go to trace, oops, not graph, trace 2.5. Enter. And yeah, y equals 285. Okay? Write down the meaning of B of 2 equals 240 for this context. So remember, B is Bert's cost, and 2 refers to the time, and 240 refers to the cost itself. So basically the meaning of that is that Bert charges 240 Australian dollars for a 2-hour job. Find t when b of t equals 510. Okay, so there's a couple ways to do this. One of them is to go into the table and then try to find where the cost is 510, or when the y value is equal to 510. You could see that that corresponds to a t value of 5. Okay, and thank goodness it corresponded to an integer value, and then you can find it. Okay, so it is t equals 5. There's another way to do it, which would work even if it didn't appear immediately here. We don't have to adjust the increment. What we could do is we could go to y equals, and we could put a value here of y, which we're looking for, 510, and then we're going to graph it. And then we could see that the 510 horizontal line crosses the blue line here, and if we find this intersection, second calc intersect, and hit enter 3 times, we can see that the intersection is at 5, 510. So basically the x value or the t value is 5 when the y value is 510. So remember, when it says b of t equals 510, it's saying the y value is 510. What's the x value? Okay, Dennis does not have a fixed cost, but he charges a higher rate of 98 Australian dollars per hour instead. What is Dennis's cost function, d of t? So remember, Bert's cost function is fixed cost 60 plus 90t. So Dennis's would be fixed cost of 0 plus 98t. So basically, he doesn't have a fixed cost, which means his line doesn't have a y-intercept either. Okay, so let's get rid of the second function here, and now let's put Dennis's in, because the next question is, at what value of t does Dennis start to cost more than Bert does? So we're going to put Dennis here also, and then when we graph both lines, now what we're going to see is that the price for certain hours of work are different depending on if you're blue Bert and red Dennis. And you can see at some point Dennis is starting to get more expensive. When do they when are they equal, and when does Dennis start to cost more, right? And so to find that out, we can just find the intersection point. Second calc intersect, and then we just hit enter 3 times. And the intersection is 7.5 comma 735. That's the intersection point. And the value of t is 7.5. So at 7.5 hours is when Dennis and Bert both cost $735. They cost the same. But then after 7.5 hours, Dennis starts to cost more. Okay, and I think that's it. Yeah, that's it.